Last time we discussed about logarithmic functions. We defined that m is equal to a to the power m, where a is greater than 0 and a is not equal to 1. It's called the base. Then the n, the index here, can be as a subject written down as n is the logarithm of m to the base a. Can write like this. On the other way, you can just giving this expression n is equal to logarithm m base a, then you can write m is equal to a to the power m. But now we want to talk about a special base. It is called the e that you learned before. And this, if you get this e, then it is called the natural logarithm, and will be denoted by log base em. But in your calculator, we will write it as ln log. So from now on, we will using ln to represent the natural log. By the definition of logarithm, the definition of natural log can be also written down like this: m is equal to the e to the power n, then n is equal to log natural log m, or natural log m to the base e. And this is a very important thing by the definition. If you replace this n to the position here, then m is just equal to the e to the power log m. So you get this one. It is very important. Why? If you have a number called a, then this one can be written down as e to the power log a. So when you have any exponential function with a to the power x, it's just equal to e to the power log a and then power x. So every exponential function can be written down as the e to the power something, which is of a constant here, and we will discuss this one later. In your calculator, just next to the log log, this is a natural log button, and here you see that if you press shift, you will get back 10 to the power x, and for this one, if you press shift, you will get e to the power x. Because it is come from the logarithm, so the properties of logarithm can be here. If you remember, there are 6 1. The sum of two log can be combined to the logarithm of the two number taking log before, which is log mn equal to log m plus log n. The second one is if you logarithm of a two number, one divided by the other, you can change it as the difference of between these two log. The first one is the log of numerator minus the second log of the denominator. If you have an expression log m to the power n, the power can be going down before the logarithm, so you get n log m. And d and e you must always remember, because it will always occur in your calculation. Log e is just log e 0, and if you remember, this one is 0. Log e to the power 0, so it is equal to 0. If you remember log a to the power x, it will be x. Here log e1, so it is equal to 1. The most useful thing is the changing base, because if you have another base like a, that you cannot press the calculator directly, so you can change the base. In here, the left hand side is base a, so it is not can be pressed in your calculator because it's not base 10 or base e. So you change them to log b over log a with natural, or even you have the common log, it is log b over log a. If you consider this example, this one can also be written down as log 7 over log 10. Then you press your calculator, the two answers are the same. If you have an example, logarithm of base 3 21, you can either write it down as natural log 21 divided by natural log of 3, or if you like to use the common log, you have log base 10 21 divided by log base 10 3. You can try this too. By using your calculator, they get the same answer. There is some example similar to the problem you learned before. Here, if you have log e to the power square root 2, you can write down like this by taking the root 2 out, and then you have log e equal to 1. But if you remember in the compulsory part, log base a to the power x, it is equal to x. So that means the root 2 will be come out directly. So when you have a problem like this, you can direct write down the answer like this. The second one, you find that there are two log added together. So by the properties of the addition of two logarithm, don't just think about the left hand side will become the right hand side. You can also have the right hand side become the left hand side. So we combine the two expressions together by multiply them and then take log. Because it is log 1, log 1 you come from the definition, it is 0. Another way to do is you can do this way, just like you have two number, one divided by the other and taking logarithm. So this expression, if you want to, you can write in like this, which is log e plus log 2 and then plus make mistake, log e minus log 2 for the first term, and then plus the log 2 minus log e. They are cancelled by the same term, log e together and log 2 together, so you still get the 0. Also, you can have another way. You can write down log e over 2 plus log also e over 2, but it is reciprocal. That means it is power negative 1. And the negative 1 can go down. This one will become log e over 2 minus log e over 2, which is equal to 0. So there are many ways to do the same problem, but you just only show one of them. Let's look at this one. This one, log of the cube root of e to the power 4. Before doing the logarithm, you must make sure that this one is in the exponential form or index form. So we will write down it is log e to the power 4 over 3. By this one, log base a to the power x, it will become x. So this is 4 over 3. Here you will get this one is equal to log of the two logarithm, one minus the other. So combine is log e to the power 3 divided by e to the power 4, which is equal to log e to the power negative 1. Again, this one you will get equal to negative 1. This is the first kind of problem that you will face in the public examination. The second kind is in terms the expression of the logarithm you have in your calculator, just like log 2 and log 3. because you can press, but your question will be not in terms here, so you change the base. Here is log 3 over log 2 by just the changing base method. This one, the first one, I changed them to become with the natural log, and because log 8 is log direct equal to 2, so you change 8 is 2 to the power 3 and 9 3 to the power 2, and taking the power outside, you will get 3 over 2, and you'll get the answer like this. In the compulsory part, we always let log 2 may be A, log 3 may be B, so you may in terms your answer in terms of A and B. Here it's just very simple, log 7 over log 5. Here you will get it is equal to log E over log 35. But log 35 is just log 7 times 5, so you have log E over log 7 plus log 5. But log E is just equal to 1, so you have 1 over the expression log 7 plus log 5. For the third kind is you want to simplify an expression with logarithm. When you're doing this kind of problem, you must make sure that all of them is in terms of the same log with the same base. Here you see there are 3 terms here, so you can combine them. If they add, you will multiply the 2 expression of the inside the logarithm, and then divide this one a squared over minus 4. So by this one you will get this is equal to a squared minus 4 in the numerator, and you cancel the 2, you will get log 1, which is 0. Another way to do that is this one. You can write down it is log a plus 4 plus 2 times a minus 2, and this one you will break down as log a plus 2 and then log a minus 2 with the minus sign on both of them, and then with the same time you cancel, you get 0 also. The second kind is also you have a log, but these 2 log can be combined to combine just the log is not the same as the natural log. So you want to make the expression in the numerator denominator with like terms which can be cancelled to here you make the expression before taking log as index form first. So root b is b to the power 1 over 2, and b squared is just here, and then take the power outside the logarithm, you will get 1 over 2 log b divided by 2 log b. These 2 log b are like terms, so you can cancel, they cannot be 0, and finally you get 1 over 4. Let's show this one. Here you will find that this is the expression, so you find that all are natural log, so you will write down like this. If you in a quick way, it is log 2 log k, 2 log k plus 1 over 2 log k in the numerator divided by negative log k. Why? Because 1 over k is k to the power negative 1, so you have minus log k and minus 3 log k. Make this numerator and denominator in terms of log k. In the numerator it is 5 over 2 log k, but in the denominator is negative 4 log k, and the log k we cancel, you will get negative 5 over 8. For this one, you will find there's a b here, so you may combine the numerator first. The numerator will be a to the power 3, because divided by ab, a keep b divided by ab, and then the denominator is 1 over 3 log a, By simplifying the expression here, you will get log a square over 1 over 3 log a. You cannot cancel it in this moment. It is not equal to log a and then power 2. So the 2 will be comes out 2 log a divided by 1 over 3 log a. This 2 log a cancel and simplify, you get 6. You do this one before, so I just show you the example. And the graph of the logarithm we will not discuss at the moment, but we want to solve the problem with logarithm and index together. If you remember in the chapter that you learn about the exponential in compulsory part, you will solve an equation with exponential, just like this one. 7 to the power 2x is equal to e to the power x plus 1. It is very difficult to find the value of x, but now we have a log, so we can take all the power, that is the index, going down and then calculate. The expression is like this. Before you taking logarithm, you must sure that these two expressions must be greater than 0, because this is the definition. You know that 7 to the power something and e to the power something are always positive, so it is okay. So you take electron log on both sides. After you take the 2x will go down and the x plus 1 will go down here. Because log e is 1, so you just have x1. This one will go back to your problem that you learned in the junior form. It is changing subject. So with the term with the x will be go to the left hand side, and the terms without x will be on the right hand side. So you will get x here, and then taking out the common factor x, you will get 2 log 7 minus y, and then divided on the right hand side, you will get the answer like this. So this one can be calculated according to your calculator to a certain of decimal. But in M1, you better leave this answer in this exact form. Now let's look at this example. Here 4 to the power 3x minus 2. So you take logarithm on both sides. It is very important when you have a log and e together, then the answer in the power will go down. So the right hand side will be 2x plus 3. And here you also put the 3x minus 2 down, but please make a bracket. Otherwise you will giving an answer which is 3x minus 2 times log 4, which is not the answer you want. Now taking the expression here, we will change that. This one will be 3x log 4 minus 2 log 4 is equal to 2x plus 3. Now changing subject, we will have x times 3 log 4 minus 2, because the 2x to the left is minus 2x, and taking out the x, and the right hand side will become 2 log 4 plus 3. Now putting this expansion to the right hand side, you will get the answer like this. Okay, this 2 can also be simplified as log 16 and log 64. Depend on what you want to express, but they are the same. The other one is also solving equation, but it is original. You must express them in a quadratic equation first. If you remember, in the index, e to the power 2x will be written as e to the power x and then power 2. And then this one is plus 3e to the power x and minus 10. That means this is a quadratic equation of e to the power x. You can do this step or just using your calculator by pressing the a equal to 1 of the quadratic formula, b equal to 3 and c equal to negative 10. Then you get e to the power x is 2 and e to the power x is negative 5. Some textbook will be writing down like this: let y equal to e to the power x. Then this one will be y squared plus 3y minus 10 equal to 0. Then y is equal to 2 or negative 5. And because you put e equal to e to the power x, so you will put it back. It is called a backward substitution. It's 2 or negative 5. But when you write it down in exponential form, this one cannot be a negative value, so you reject this one. And finally, you get the same answer, which is equal to log 2. Let's look at this one. If you are not familiar with the expression like this, you will write down like this. Let y equal to e to the power x. Then this one is 2y squared minus 9y plus 4 equal to 0. So you will get it is equal y equal to negative 1 over 2 or 4 by using your calculator. But y is just the e to the power x. It is equal to 1 over 2 or 4. By taking logarithm, x will be log e2 to the power negative 1, so it's negative log 2 or log 4. Because here you find that e to the power x both are positive numbers, so there's no rejection. The other kind of problem is the logarithm equation. You did it in compulsory part. When you have the left hand side, you add the two together, so you combine to be a product and then take logarithm. Because both sides have the logarithm, so you can take out the expression inside here. Here I want to emphasize you are not cancel the logarithm, not cancel, because the expression inside the logarithm must be equal because they are equal. So we have the things inside must be equal and form a quadratic equation. You can omit this one and then get the answer like this. You must remember when you're taking logarithm like this too, this one inside the logarithm cannot be negative. If you putting x equal to 1, it is not 5 and this is not 2, it is okay. But when you putting negative 5 here, it is not negative 1, which is impossible, so you reject. You just want to check, you need not to show how this works. Then you want to just to say that it is reject. Let's look at this one. This one you can combine them to become not 3x minus 5 over 4x equal to 1. 1 is just not e. If you remember, no need to do anything. That means the expression here is 3x minus 5 over 4x is equal to e. And putting the 4e to the right and changing subject, you will get the answer 5 over 4e minus 3. This is the consolidate of the logarithm by using the base e. This section we are talking about the application of exponential growth and exponential decay. Before the holiday, we just learned about what is the compound interest. It is a kind of exponential growth. We will write down like this. The amount is just the principal e to the power RT over 100. R is the interest rate per annum. That means 1 year you will have how many percent. And we want to have the interest at any moment, so it is called compounded continually. If you don't forget, if you may take a look at your textbook. And on daylight problem, we always have exponential growth, so we must have the curve of this one. Exponential growth will be the curve like this. You just remember this one. We will discuss this one in the compulsory part. But in your compulsory part, we have the tail here, up here. Why we do not have the tail here? Because we are considered the time. Time is running from 0 only. That means the domain is starting from 0. So we do not have a graph on this left hand side. If this is called exponential growth, means that it is just Q naught. Q naught is called the initial value. Initial value. It must be positive, okay? And also e to the power kt, and k is positive. You must sure it is positive. So we will have a graph. We will growing up. It is not a straight line grow up. It is will bend like this. If you consider the first one, you have a straight line like this, but this is bend more rapidly. You know that the compound interest, if you compound continually, will be better than just a simple interest. And we always starting with the t equal to 0, then the q, by putting here you will get q naught e to the power 0. E to the power 0 is 1, so q naught. So q naught is called the initial value. Let's look at an example. 5,000 red ants are found to migrate to a park in a certain day. 10 days later, there are 30,000. You see the number of ants is increased, so it's an exponential growth. And anthropometry predict that the number of ants of red ants in the park t days after the migration is given by here. Here you will get n is your number at any time t. And this is expressed as an expression like this, and not it is called the initial value. How to calculate? You may put the t equal to 0 to get, and then you will get another thing that you want to find the constant k, so you must have another value, that is 10 days later. That means the t is equal to 10, because t is measured in the days after the migration. When 10 is equal to t equal to 10, and then the n will be 30,000. So you put the value when t equal to 0, n is 5,000, so you get n naught is 5,000. And then you putting the n naught is 5,000 in the expression here, so you put t equal to 10, you will get 30,000 is equal to 5,000 e to the power k times 10, which is e to the power 10k. So you will get an equation that you just learned. 6 is equal to e to the power 10 to the power k. It is an exponential equation. So if you want to solve it, you must take log on both sides. So log 6 is equal to 10k, and solving k will get log 6 over 10. So you can put the log 6 over 10 inside the expression to get an n log with 5,000. Then you will get 5,000 e to the power log 6 over 10 times t. Make sure you will make a bracket here, because the t will be a separate symbol for calculation. Okay. Now when you want to calculate how many ants after 20 days. So that means you put the t equal to 20 inside the expression. Now before you doing that, you must simplify the index here. 10 and 20 is 2, so you have 2 log 6. Why this one is log 36? Because when you have 2 log 6, the 2 can go inside to the logarithm. So don't just consider the properties is just left hand side to the right hand side. You can have the right hand side become the right hand side. So it is log 6 to the power 2, so it's log 36. By the definition we just mentioned before, e to the power log 36 is just 36. So you get it is 18030. It is 180 thousands. Now let's show you the problem like this. In a certain bacteria culture, the number of bacteria after t hours is given by this one. So that means this one you are giving the n naught is equal to 150, and so you will it is known that 660 bacteria after 4 hours. So you put t equal to 4, n will be equal to 150. So you become 660. Sorry, I made mistakes. So 660 is equal to 150, and e to the power 4k. So I will get e to the power 4k is just equal to 660 divided by 150. If you simplify, you will get it is 22 over 5. Sorry, mix this thing here. 22 over 5. So you will get 4k. By taking logarithm, this one will become 4k, and this one is log 22 over 5. And putting the 4 here, you have k equal to 1 over 4 log 22 over 5. It is the k value. And if you press your calculator correct to the 4 decimal place, you will get 0.3704. In the DSE, M1 always take a 4 decimal place. What will be the number of bacteria after 1 day? You know that 1 day is 24 hours. So the n is just equal to the 150 e to the power 1 over 4 log 22 over 5, then times 24, which is 115 e to the power log 24 divided by 4 is 6. So inside it is 22 over 5. Sorry. Power 6. Power 6. So that means I can get the answer E log the expression. So you have 150 times 22 over 5 to the power 6. And after you press your calculator and correct to the nearest thousands, you will get the answer is equal to 1088000. So here you will no need to calculate this answer yet. If you just using this answer to put down here, then multiply by 24 and then exponential, you will have a error in calculation. So better using the exact value inside the second part. This one is called exponential in the growth, so you will grow up like this. And how about exponential decay? It is similar to that, but this one will change to negative. Negative means that this one will decrease, and the q that these two values is also keeping positive. So you will find here q naught e to the power negative kt. Both k and q naught still are positive, but there's a minus sign, so it will indicate this is decrease. Decrease will be like this, like this one, okay? And also it is also called the initial value when t equal to 0, the q naught. This is a similar example. The concentration Q of a pollutants in harbor after t years from 2009 is given by this expression, and Q naught is a constant when t is equal to 8, Q is equal to 100. So you have given two information. The first information is the pollution is the concentration of the pollution from is given by this one. So when you are getting the pollutions, you want to calculate the Q naught first. So you because you have to not know the initial pollutions in so you must using this data by putting t equal to 8 and q equal to 100 and solving this one you press your calculator, you get 261. So find the concentration of pollution in the harbor in 2024. So you must know 2024 is how many years after 2009, which is equal to 15. And the value you calculate here, Q naught, is 261, but you do not using this answer. You must take a more accurate answer, so you have more significant figures. So you have 261.17, and put here, you will get 43.2. And then you will get the answer like this. Let's look at example. It is giving the proportion F of electric lamps manufactured by a factory that can work for T hours or more is given by this one. You give the proportion. Proportion means that it is out of the total number, which is divided by the total number. So it's just a number between 0 and 1. 0 and 1. The factory guarantees that each lamp can work for at least 3 years. Otherwise, it can be replaced free of charge. What percentage of lamps will be replaced free of charge? Now you are giving this F is just like the Q equal to Q naught. Q naught here is 1. Why Q naught is 1? Because when you manufacture, we assume all the lamps are work. So the proportion is 1. And this is e to the power negative 0.09. Here is a minus sign that indicates this one you will decreasing. That means here you will have a graph like this, and this one will decrease. Sorry. I cannot draw this one to here. You must cut the one here. It is 1, and this is the fraction, and this is the time. This will decrease like this, and you want to find the percentage. That means when t equal to 3, so you draw a number. Sorry. This is 3 here. You want to find what is the percentage that will be released will be here. Okay, so we will calculate. which is equal to F is equal to e to the power negative 0.009 times 3, which is equal to e to the power negative 0.027. Now press your calculator, you will get the answer. Shift the ln0, that is the e to the power minus sign 0.2, you will get it is approximately equal to 0.97336 something, okay? But this one is the lamp that is work. You want to replace means that you want to find the percentage that it is out of this range. So the percentage is equal to 100% minus this 97.336%. Which is equal to 2.66%. Correct to 3 certificates. You will find always we get the answer, which is 1 minus the remaining part in the DSE. So you must remember this. What is the durations that 90% of them can work? That means the fraction will become 90. So you get 0.9 equal to e to the power negative 0.009 t. So taking logarithm on both sides, you have log 0.9 equal to negative 0.009 t. You know that why we have a negative. When you're taking a logarithm, which is the number is less than 1, you learned that in the compulsory part, it will be a negative answer here. So negative divided by negative, you will get a positive t. So that means the t is equal to log 0.9 divided by negative 0.009. Don't forget the negative sign. So it is approximately equal to 11.7 years. This is a kind of problem you do not find in the compulsory part, so you may pay attention. And the example here, the number of undecayed nuclear, undecayed, that means remaining nuclear here in an radioaccident is T years is by this formula. Find the number of nuclear in the radio. So you putting the T equal to 10 and you get the answer is 6,570 correct to 3 decimal place. What is the time required the number of undecayed nuclear to half of this initial value? If you want to know the time, you must know what is the half value of the its initial value. So you find the initial value by putting t equal to 0, or you just look at this expression, you just say this one is the initial value, and divided by 2 is the half. So that means the 5,000 is equal to 10,000 e to the power 2, and then solving the problem just like this example, and then you will get the exact answer is t equal to log 2, negative log 2 over. So you have a minus sign here, okay? And you will get 16.5. Let's show an example. The number of undecaying Q in a radioactive substance T years is given by this where Q naught and K. Here is a minus sign, so this is a exponential decay. It is known that the number of undecaying will be 1/4 of initial value after 50. So that means when t equal to 50, the Q will be the initial value of 1/4 of the initial value. So it is Q naught over 4. Because you do not have the Q naught, so you just write down the Q naught here. So by putting Q naught over 4 is equal to Q naught e to the power negative k times 50. So you will get, so this is equal to Q naught equal to e to the power negative 50k. And Q naught and Q naught you do not know, but here you can cancel because they are not zero. So you will get 1/4 is equal to e to the power negative 50k. You have two ways to do that. The first way is you taking log on both sides. Log 1/4 equal to by taking log it is negative 15k, and the k will calculate is like log 1/4 divided by negative 50, and you will get this answer 0.027. The other way is like this. We don't like the negative, but if you want to make this one, you will have a reciprocal. That means you power negative 1 on both sides, and you will get 4 here. This one power negative 1, you will get 1/4 reciprocal, you will get 4. And here negative power will get e to the power 50k. And taking logarithm, log 4 is just equal to 50k. And press your calculator, calculating k is equal to log 4 over 50, you still get this answer. And the last one is if the initial number on decay is 10 to the power 6, find the number of 18 years. So you put the k values, it is equal to log 4 over 50. In this expression, so we will have the number of nuclear after 18 years is equal to 10 to the power 6 initial value times e to the power negative log 4 over 50 times 80. And you will get this one is equal to 1 with 6 0. This 80 and then divided by 50 is 8 over 5. So you will get this one is just equal to 4 to the power negative 8 over 5. By using your calculator, you press 1,000,000 times 4 to the power negative 8 over 5. You will get the answer 108800. The last example, a power plant is built near city and environment that here. This is not a purely exponential graph because it is a number minus an exponential. How to do this one? You must first know what is the graph like this, and then how this one work if you have a 6 minus this one. How long it will take for the weight of the pollutant in the air to become 3 million gram per year. So we put the W equal to 3, and solving, we get the exponential form and find out the equation. It is t equal to 0.34. You want to plot the graph of t of w and t equals 0, so you put the value of 0, 1, 2, and 3 by the table, or even more point to make sure you will get the graph like this. And then after you get the graph, you can find out the answer. From B, estimate the pollutants of the air city when a long of time. Very long of time, that means you overrun, then you will go to the 6. So we say that this one will become 6. This one we'll discuss later, the next chapter, about limit, and we will discuss this kind of called a limiting case to do that. How to mention this graph? You will follow like this. Your original graph will be like this, so you first plot phi e to the power negative 1.5t first. That means this part. The graph will be like this. First, it is a negative 1.5, so it is exponential decay. And the time here, cannot cut the x-axis. This is the time, and here it is equal to 5, because when t equal to 0, it is 5. So this one is the it is the exponential of here t, but I don't know what is the expression here. You can maybe add x. Now this is a phi, but if you minus means that you everything take a negative, so phi will take a negative phi here, so you get a graph like this. This t-axis, not x-axis, because this t here, it's just a refraction about this axis, so you fit here, and the value here is just equal to 5, negative 5. So the graph shape will be similar to that. But this is not the final stage, because you just doing that, it make this one become negative 5 e to power negative 1.5t. So this one will moving upward with 6 unit. If negative 5 moving 6 unit upward, this point will be go to the 1, and this 5 will moving to the 6. You add 6, this negative 5 will be moving to the 1, and this point will moving up to the 6. So you will get all the graph moving 6 unit upward will form a graph like this. This one also will discuss later, but I want you to know this one at that moment. And the example practice here, you can do it by yourself, okay? And you need not to if you have problem, you can ask me through the email about these questions. This is the end of these sections.